welcome back. So in this video, I'm going to cover the exponential smoothing technique for time series data. And this is a method that I do like. So what we've got to do here, well, let me start off. This is on page 753 to 756. So the idea here is we've got what we call this smoothing constant, constant, and we call it alpha. So I need an alpha. Now I'll go through the example in the book so that you can reference everything, but our smoothing constant here is 20%. And so the idea here's going to be our exponential smoothing forecast. Okay. Whoa. Oh, that didn't work out well at all. Okay, there we go. Okay, so the idea here is I'm going to take my smoothing constant and it's going to be a weighted average. Well, I'll just be that. It's going to be a weighted average of two things. It's going to be the weighted average. So if I'm looking at, say, period 3, I'm going to take alpha times the actual sales in period 2 plus 1 minus alpha times the forecast in period 2. All right? And so the question then becomes, well, what's the forecast in period 2? Well, as your book explains, the forecast in period 2 is just your period 1 forecast. Okay? Now, I should stop here and say, look, your book does a great job of explaining this to you. Despite what I just said, that I'm going to take alpha times the period 2 sales plus 1 minus alpha times the period 2 forecast, it can be shown that the exponential smoothing technique actually takes into account all of your data. That is on page 754, that first, say, I don't know, like the first third of that page. I strongly encourage you to read through that. It's not very difficult. They're just doing some substitutions. But the point is, it can be shown that the exponential smoothing forecast for every period takes into account all of the data from all of the previous periods. So again, I happen to like this methodology because I'm using all of my data. All right? So how do we go about actually doing this? So what you're going to do is you're going to take the actual sales in the prior period, multiply that by your alpha, and then add to that 1 minus your alpha times the forecast in the prior period. All right? One too many. Yes, I'll accept that. Okay. Now, to make life easy on you, anchor the cell that contains alpha. So I'll put a $sign here and a $sign here. Copy that down. Presto. There is my exponential smoothing forecast. All right? And then, once we've got all this stuff, we can calculate our accuracy. So, absolute value of the forecast error. All right? And so, again, this is the ABS of actual minus forecast, although it doesn't matter what order. I'll do that. Copy that down. And then same thing, calculate the average. All right, so average of this. Voila. And then I have my squared forecast error. Wrap. Okay, so that equals this number squared. And then, same thing, take the average. And yes, as always, I like to take the square root of that. And then I can do the ABS of my percent error. And so that is this divided by actual sales. Copy that down. Copy across the average, right? Okay. Now, you may be saying, well, wait a minute, Professor Lesh. You know, what's the deal? How do you pick alpha? Great question. And your book talks about this. And this is one of the reasons why I happen to be a fan of exponential smoothing. Yes, you can use the trial and error method. It turns out, though, that there is actually an easier way using linear programming. And don't freak out on me, because this linear program is so easy. You have basically got it all set up. So if I want to find the alpha that minimizes, say, the forecast error, the squared forecast error, or the percent error, right? Now, your book recommends minimizing the average of the squared forecast error, which I happen to agree with. This is a good one. But I'm also a fan of the absolute value and the percent error, right? So I'll just show you how to do this on the squared forecast error, but it is really, really easy. You're going to love this linear programming problem. So all you have to do is go into Data, Solver, and what you want to do is I want to minimize the average of my squared forecast error by changing alpha. That's it. There are no constraints, nothing else. Check the non-negativity, non-linear. This is a non-linear program. Hit solve, hit OK, and voila. Here is the alpha that minimizes the average of my squared forecast error. All right? So this is one of the reasons that I do happen to like the exponential smoothing, because we have a very nice way of calculating the alpha that minimizes one of your forecast errors, right? And then to wrap all this up, the idea is, at least in my mind, when I do this stuff, is I do two things when I'm trying to forecast stuff. I take the average. That was in that video, 2 or 3 videos ago, where I just take the rolling average, if you will, right, to forecast period 13. So my forecast for period 13 would be the average of periods 1 through 12, right? And then what I do is I calculate my ABS forecast error, squared forecast error, and ABS percent error. And then what I would do is I would actually do the exponential smoothing, minimize that value of alpha that, say, minimizes the squared forecast error. And then what I would do is I would compare these forecast errors from exponential smoothing with the forecast errors from just taking the average itself. And whichever errors obviously were the smallest, that would be the method that I would use to forecast period 13 sales. So in my own work, I just use that average methodology and exponential smoothing, right? Minimize alpha, and then compare them. I compare their errors. And whichever one has the smallest error is the one that I go with. Now, I have to be honest with you, sometimes it gets a little funky. Sometimes one method will have a smaller ABS forecast error, but say a higher ABS percent error. Well, there is no hard, fast rule that says, oh, we'll pick ABS forecast error over ABS percent error. The general rule is you try to minimize the average of the squared forecast error, but you can use these others. But the point that I'm trying to get at is when you're picking the right forecast methodology, it's really kind of up to you. Which methodology do you think is going to give you the most accurate forecast in period 13? And then finally, I do want to say one other thing. A lot of this forecasting that we do, it's really only valid for, say, the next period or 2 at most. Don't go hog wild on your forecast. What happens, and the book doesn't talk about this, But what happens is the farther out that you forecast, the bounds on the error start to grow. And so the quality of the forecast really starts to diminish as you go out farther and farther. And so I would recommend, when you're using, say, either the exponential smoothing or the average method, in all honesty, I would only forecast out 1 or 2 time periods. In my own work, that's all I do. I don't go beyond 2 time periods because I know that the error around my forecast is just growing almost exponentially, right? So be careful with that. Okay, well, that's it for this week. So we've gotten through sections 5.1, 2, and 3. These are some basic forecasting methods that you can use when you have stationary time series data. All right. Again, I want to stress that because the whole point of graphing everything was to see if your time series was stationary, right? In other words, did it just randomly fluctuate about a mean? And the reason that this is important is because really what you're trying to do with exponential smoothing and then that average technique is just find out what that mean is, right? Because that mean is going to be your best forecast for the next period. Again, we can't forecast random fluctuations by definition. That's the whole point. They're random. They just occur. And because there's no systematic relationship between, increasing or decreasing, we can't forecast that, right? In order to forecast something, we need to be able to see a systematic relationship. And the whole point is when it's random, there is no systematic relationship. So these exponential smoothing and the averages are, in my view, the 2 best methods to use when forecasting stationary time series data. Now, next week, we're going to get into the linear trend model and the seasonality model. And these are methods that we're going to use to forecast data that obviously is not stationary, right? We're going to model data that has a trend in it. And then we're going to model data that has some seasonality into it, okay? So that's what we'll do in the last week of class. Well, that's it for this week. I will see you all in class.